this factoring stuff first, because if you can't do this, rationals is impossible. So we're just reminding ourselves about these. These are really, really easy. Like I said, these are the easy factoring. You guys in 20-1 and 20-2 trinomial factors like crazy. We don't have that. Okay, life is good. So what we need to remember is 1. If there's 2 terms. What I'm going to check first for is a GCF. And then I'm going to check if there's a difference of squares. Now, what does difference mean? The difference of 2 numbers. What does difference mean? Subtraction. Absolutely. So a difference of squares needs to have a subtraction sign between of 2 square things. Like 4 is a square, or 9 is a perfect square, or x squared is a perfect square. So it's a difference of 2 squares. That's why it's called difference of squares. Whoever made this word up, like little definite, ingenious. Like really, a difference of squares. Like couldn't get any better. Like sometimes I'm like, I don't know where they came up with this term, but that genius. Okay, so difference of squares, GCF difference of squares. Those are only 2 things. If it's 3 terms, product sum, decomp, yeah, but we are going to look for GCF, and then we're going to move on for the most part. Okay. So example 1 says factor. Whenever you are asked to factor, you must always check for GCF, greatest common factor, first. Can I take something out of all the terms? Okay, so you're going to ask yourself. So that's the first thing we ask ourselves on A. Is there anything I can take out of 25d to the 5 plus 45d to the 4? What? 5d to the 4. Now, if you're someone who's never ever understood GCFs and you're like, I have no idea, I just guessed. What this is this really is just 25d times d times d times d times d times d plus 45 times d times d times d times d. So what was the common amount of d's you could take out of both? 4. That's why. You always take out the smallest amount because it's the common amount that you can take out of them. And then what can you take out of 25 and 45? A 5. So you can take a 5 out of the coefficients and 4 d's. Can't take out 5 because the second one doesn't have 5. Okay? So we're going to take out a 5 and d to the 4, which is just d times d times d times d. Right? 25, when you take them out, when you take out a GCF of anything, you're really doing what operation? Dividing. So what's 25 divided by 5? 5. And then d to the 5 divided by d to the 4? D to the 1. Now the reason why you're dividing those, yes, you are going d to the 5 divided by d to the 4. But remember when we have common base, what do we do with our exponents? Subtract them. So even though we are dividing, we are really actually subtracting the exponents because we're dividing common base. So we're going to be left with 5d plus 45 divided by 5, 9. D to the 4 divided by d to the 4 is actually close, 1. D to the 4 divided by d to the 4 is actually 1. So we could go times 1 behind it. Do we have to? No. The reason why it has to be a 1, if it was a 0, it would be 9 times 0. And what's that? 0. And that's not true. Right? Boom. And equal signs. Now, equal signs are important, not because I'm just a stickler. They're important because if not, you have random stuff floating all over your page, meaning nothing. Like if I just have this, this, and this, even if you have them in nice order, you really have something. And then below it, you have something floating. And then below it, you have something floating. And you just have floating things, which are fantastic. However, you want me and everyone else to know that this expression equals this expression equals this expression. Then I box it, and we're all happy. Okay? We have equal signs because they equal each other. It tells something about the expression rather than just some random math and you hope I know what you're doing. Okay? B. What do I ask myself? And I can't. And that one's not a difference of squares anyways, because even after I take the GCF out, what's in between the 2 terms? A plus sign. Oh, wait. B. What could I do? Take out what out of 9, 12, and 6? What's the biggest thing I could divide them all by? 3. and then a k to the 4, a k to the 3, and a k. So the first one has 4 k's, the second one has 3 k's, the last one is 1 k. What's the biggest amount of k's that I can take out of all of them? 1. Okay. 9 divided by 3 is 3. K to the 4 divided by k is k to the 3. Because when we divide, we actually subtract. Common base. 12 divided by 3 is 4. K to the 3 divided by k minus negative 6 divided by 3 is, so we have a negative 2. And then k divided by k, 1, but we don't have to write it. And we're done. I want you to try C, D, E, and F for right now. C, E, F, and D. Try those ones out. We'll go over them in like... Okay, if we look at C, we have 8x squared plus 10x. What can I divide out of 8 and 10? That's the biggest thing I can take out of them. A 2. And x squared and x, an x. 8 divided by 2 is 4. X squared divided by x is x. Then 10 divided by 2 is 5. X divided by x cancels. D, what can I take out? 4. 12y divided by 4, 3, and then y. Negative 16 divided by 4, negative 4. Now, E, some people will have taken out a positive 15, some people will have taken out a negative 15. Which is more correct? Neither. Most of the time, the negative will help you, though. So if the first term is negative, sometimes it will help you. What you're going to find in rationals is in rationals, you have something, like something to factor, over something else. Okay? So what you're going to keep in mind is you need to cancel something off the top and the bottom a lot of the time. So you're going to have to get them to look exactly the same. So sometimes taking the negative 15 out, they'll match. And sometimes taking a positive 15 out, they'll match. So it just really depends on what rational you have. Okay? Right now I'm going to take the negative 15 out. If you took positive 15 out, you're not wrong. Okay. So I take out a negative 15 and a d to the 3. And I'm left with negative 15 divided by negative 15 positive 1. If you took out a positive 15, you're going to have a negative 1. D to the 2 minus 45 divided by negative 15 is 3. Now d squared minus 3 is not a difference of squares. The reason why is 3 is not a perfect square. If it had been 9, we'd be in a different ballgame. Like if it was d squared minus 9, we'd keep going. F, can we take anything out? F is a trick. It's done. Okay, G. What could I take out of G? C. Make this be a plus C, please. Just for ease, so I can show you something. So if we make that be a plus C, if it's a minus C, everyone will put minus 1 and be correct. If it's a plus C, I get errors all the time. So we can take out a C, that's it. C cubed divided by C is C squared. C squared divided by C is plus C. And then positive C divided by C is a 1. It's not a 0. It doesn't go away. If you take a GCF of the exact same thing out, you get a plus 1 at the back. Don't just get rid of it. If you wouldn't have put a plus 1 back here, if you would have gotten rid of it, leave yourself a note and say, no, don't do that. When you take the C directly out of the C, it's a plus 1. This is a very different looking thing than C squared plus C, is it not? Like if I got rid of this back part, that looks very different than this, does it not? It is different. It's wrong. So don't do that. Okay? So if you GCF the exact term out, you're left with a plus 1. If you GCF the exact term out and that had been a minus C instead, you would have been left with a minus 1. But most people will put minus 1 and they'll drop off the plus 1. Okay, that's why I told you to change it to a plus C instead of a minus. Okay, H, what could we do? Take out a 6. And we're left with n squared minus 5n plus 7, which does not factor. Nothing multiplies to give you 7 and adds to give you negative 5. So you're done. I want you to go down to k. So with k, what could I take out in k? Yeah. Just the 2. So you could take a 2 out and you'd be left with 9x squared minus 25y squared. Okay? It's the only thing that's common is the 2. Now, 9x squared minus 25y squared is a difference of squares. Why and how do you know? Well, if you have a different sign first, you have to check. So I have a different sign, so that's my first stipulation. So it's looking okay at this point. I have a different sign. The next thing I have to look for is, are the terms on both sides of the different sign perfect squares? What the heck does that mean? That means if I take the square root of them, I don't get decimals. So if this was 9x, it wouldn't be a perfect square. Because the 9 would be a perfect square, but the x wouldn't be. Okay? So I'm going to try it out. I'm going to square root the 9x squared. What do I get? 3 and square root of x squared is x. Okay? Square root 25y squared, and I get 5y. So they are a difference of squares. If I square root them and they're perfect numbers, no decimals, they're a difference of squares. And they have to have a different sign between them. If this had an addition sign in between it, I'd be done. You can't do anything with it. Okay? So the 2 carries down, and this splits into 2 factors. The 9x squared minus 25y splits into 2 factors. Nine x squared, the square root of it is 3x. It goes to the front of both brackets. And then we have a 5y, and that's going to go at the back of both brackets. And then the only way if we foiled this back that we wouldn't get a middle term, because we could FOIL these back to this, could we not? The only way if we FOIL these back we won't get a middle term because there's only 2 terms, is if we have a plus and a minus. You need to have opposite signs. So I could go positive, negative. I could go negative, positive. Does it matter? No. What matters is that they're opposite signs. Done. Okay? And flip over. Knowing that, try these out. So when we square root b squared, we get b. When we square root 64, we get a. So our factors are going to be b plus 8. I just said a instead of 8. I don't know why. B minus 8. Square root of a squared is a. Square root of 144 is 12. A plus 12. A minus 12. And you guys, you need to be able to spot them. Okay? You need to be able to spot difference of squares. That's often where people are like, I can't get to cancel anymore, Mrs. Lepp. I'm like, because you didn't do a difference of squares. So you have to be able to spot them. 9a squared minus 121, 9a squared. Square root of that is 3a. Square root of 121 is 11. So you're going to get 3a plus 11, 3a minus 11. X squared and 81. Square root of x squared is x. Square root of 81 is 9. So you're going to be left with x minus 9, x plus 9. If you did x plus 9, x minus 9, you're still fine, right? It doesn't matter as long as they are opposite signs. Square root of 324 is 18. A. Square root of 279 is 17. So you get 18a plus 17. 18a minus 17. Now, 81 minus m squared, you will have it this way, I'm sure, most of you. 9 minus m, 9 plus m. But sometimes that's not the nicest format. Sometimes they want to have the m's first, and it's all dependent on, when we do rational expressions, what factor you're trying to cancel off the denominator or numerator, right? So what you could do, just keep this in mind, this answer is correct. It's not wrong. But what you could do is you could take a negative 1 out first. If you took a negative 1 out first, and then I would reorder them in a second, but if you took a negative 1 out, you get negative 81 plus m squared, which is actually the same as take a negative 1 out, m squared minus 81, right, if I just reordered them. And I can reorder them. There's no saying that because it comes first, it has to stay that way. All that's when you reorder them is that you have to take the sign that's in front of them with them. So positive m squared minus 81. Okay? And then we're going to get negative 1, m plus 9, m minus 9. Now some people will say, well, how is that any better? It isn't in this case, but it might be if we need an m minus 9 in the denominator. Now, what happens if you factored it this way? Could we not have just taken a negative 1 out of this front term and it'd be m minus 9 to fix the issue? Could have done it that way too. Okay, this one, we're going to get 5x plus 1, 5x minus 1. And then here we're going to get 2x plus 6, 2x minus 6. Yep. So if you do it this way, which some people do, you'll still get the same answer, but what do you have to do after? Now you have to take the GCF out. So now, don't write this if you did it the correct way. You can take a 2 out and you're left with x plus 3. Take a 2 out and you're left with x minus 3. Now this 2 and this 2 combined, because these are all just what? They're all just multiplied, correct? So you'd actually end up with 4x plus 3x minus 3, which is correct, but you did more work. So that's why I said your step 1 should always be what? GCF. So if you took a 4 out at first, you would end up with x plus 3, x minus 3. Okay? Same answer. Less work, less chance of making an oopsie. So always remember that GCF always happens first. Doesn't matter what kind of terms we have. Okay? All right. So all of that was just remembering. Okay? Today we're going to end with non-permissible values. So NPVs, non-permissible values and restrictions, are what the variable cannot equal or your denominator. Denominator is the what? What's the denominator? The bottom will equal 0. And you can never, I guess I should say, divide by 0. So we've never had to state non-permissible values. Well, in 20-1 you did, because you did rationals. It's kind of a repeat unit. But you've never had to state rationals until this point in this curriculum, because we've never had variables in our denominator. We've just solved things, right? We've never had a variable in the denominator. And so now what we actually have to do is we have to state non-permissible values because we're going to have a letter in the denominator. And that letter can represent anything, correct? It can represent 1.7777. It can represent pi. It could represent negative 400. You know, the only thing that it can't represent is the denominator can never be 0. Because if you went 3 divided by 0 into your calculator, it'll say error. If you do negative 100 divided by 0, it'll be error. The only thing that can't equal 0 is your denominator. So what we're going to do, because we have variables and letters in our denominator, is we're going to say what those letters can't be, because if they were that, our denominator would be 0, and that's a problem. Okay? So, steps to find NPVs. We need to GCF or difference of squares a denominator first. We actually don't care. If they ask for an NPVs and nothing else, we don't even care what the numerator is, what the top is, because NPVs come directly from the denominator, what it can't equal. Make sure your phones are away. Something new. So here, we need to determine the non-permissible values. What does non-permissible values stand for? Non-permissible values. Values that are not permissible. Ones that you cannot use. Like it, now, once again, very good use of words here. Like difference of squares. Difference of squares. Non-permissible values. Not permissible values. Values that are not permissible. Weird. Awesome. This is good. These are good terms. Okay? So, what we're going to do is not care about the top, because can the top be equal to 0? Yes. If we do 0 divided by 1, our calculator will tell it's 0. That's fine. We just can't have our denominator equal 0. Okay? So we have x plus 1 over 5x squared minus 5x. So the x plus 1 is just going to say x plus 1. And if I could factor it, I wouldn't, because I wouldn't care. I don't care what's in the top. It could be a smiley face for all I care. It could be a cat. Don't care. They can put whatever they want up there. Okay? Because all I'm asking you for is for non-permissible values. So I have 5x squared minus 5x. It's the very first thing I always ask myself. GCF. So what could I take out? 5x. When I take a 5x out, I'm left with 5x squared divided by 5x, an x, negative 5x divided by 5x, minus 1. Now this is what I'm going to hazard you to do, please. Now, the x minus 1 is in brackets, correct? They're connected by a subtraction sign. Anything that's this is hard. Anything that is connected by a subtraction sign or an addition sign is sewn together. It's like stitched together. They cannot come apart. Okay? You can't like cross off the x. You can't cross off the 1. They're friends. They're stuck together. Okay? Anything, however, that is connected by multiplication signs is good to go. You can disconnect them at any point in time. But addition and subtraction signs, they either all go together or they don't go at all. Okay? But multiplication, you can move them all around, correct? So this 5 and this x minus 1 are all multiplied, are they not? So what I'm going to do always is anything that's connected with a multiplication symbol, I'm going to put in its own brackets because it's its own entity. And I could move it around all I wanted. So I'm going to put the 5 in its own brackets. A lot of people think the 5 and the x are attached. Are they sewn together? Is there a plus or minus sign between them? No. And this is separate, and so is the x minus 1. And you know they're separate if you can take them and move them all around anywhere in that denominator, and you still have the same thing. So could I go x times 5 times x minus 1? And it'd be the same thing? Yes. Could I go x minus 1 times x times 5 at the back? Yes. I can move those all around. Can I take this x that's with the x minus 1 and move it here and leave the minus 1 at the back? No, they're stuck together, so I can't separate them. Okay? Why is it so important? For 2 things. When you do multiplication and division and simplification, it's way easier if you put them in brackets. You won't cross off wrong things. And second off, you put them in brackets, NPVs are way easier. So what we're trying to figure out is what can these x's not be, that if they were that, this denominator would become 0. Okay? Well, this is a 5. Can a 5 ever be 0? Not a trick question. It cannot. It's a 5. Okay? You're not getting an NPV from the number 5. It is a 5. It's never changing. Okay? So no non-permissible values coming from that. We have, if you really want to, you can say 5 cannot equal 0. True. Yay. Not an NPV coming from there. Okay? Then we take our next bracket and we say it can't equal 0, right? Because if anything in these brackets turn to 0, 5 times x times 0, the denominator would be 0. If the x turned to a 0, it'd be 5 times 0 times x minus 1. My denominator would be 0. So if any of these brackets could somehow turn to 0, the whole denominator turns to 0, which is a problem, right? So I take my brackets and I say they can't equal 0. 5 can't equal 0. X can't equal 0. X minus 1 can't equal 0. Okay? And I just solve those for x. Well, this one already is. X can't equal 0. Okay. Bless you. And then this one, we move the 1 over. And we say x can't equal 1. Now, when you walk away from your non-permissible values, you should know if you're right or not, because you can plug them back in. And if you plug them back into your denominator and your denominator turns to a 0, you're golden. You have the right Npvs. Okay? So I'm going to try the 0 one. I'm going to plug it in. 5 times 0 times 0 minus 1. Well, that's 5 times 0 times negative 1. What's that? 0. So my denominator turned to 0. So this is an Npv. Yay. Now I'm going to try the 1. 5 times 1 times 1 minus 1. What's 1 minus 1? 0. So we have 5 times 1 times 0. 0. So I'm good. So my Npvs are x can't equal 0 or 1. If x equals 0 or 1, my denominator would turn to 0, and we have problems because we can't have our denominator equal 0. Okay? State the restrictions on the variable. The restrictions on the variable are what the variable can't be. Exact same thing. Why the heck would I put that as an A and a B? Because I want you to know that the word restrictions or non-permissible values can be used to mean the exact same thing. So if they ask you for the non-permissible values or they ask you for the restrictions, they are asking you for the exact same thing. Just different words. So we're going to look at example 2. Example 2 says, determine the non-permissible values restrictions for each of the following expressions. So do I even care what the numerator is? Do I care? No. The denominator is a minus 1. So I have to ask myself, because there's not more than one of me, I just said myself. Yep, I'm not plural. Okay, can I take out a GCF out of that a minus 1? No. Is it a difference of squares? No, it's an a minus 1. So 3a minus 1 on the top, yay, don't really care. And on the bottom, I have a minus 1. And I'm going to connect it with brackets. Why? Because they're sewn together. And I only have one bracket, so this is easy. I take my bracket, I put Npvs. A lot of people want to say MVPs because of most valuable player. It's not, it's Npvs. Okay? Non-permissible values. And we take it and we say a minus 1 can't equal 0. So a can't equal what? 1. We add 1. And now we should be able to check it, and our denominator should turn to 0 if these are right. What's 1 minus 1? 0. Yay. Right? What about B? What could I do to B? Take out a GCF. What could I take out? Not a 2. Nope. Just a K. 2k squared, take out a k, and I'm left with 2k. Negative k divided by k, I'm left with negative 1. What if it was k divided by k? What am I left with? 1. And you have to put plus 1, or your Npv is going to be wrong. Because you're not going to subtract the 1 over and divide by 2, right? Okay. This k is by itself. It goes in brackets. Why don't I put the 2 and the k in their own brackets, and then this negative 1 just hangs out at the back or something? It's all connected. 2k minus 1 is one entity. The 2k is attached to the 1 and by a minus sign. They're sewn together, right? They're not getting separated. So now I have two nice factors, correct? So now I can take them both off to the side, and I can say Npv. K can't equal 0, and 2k minus 1 can't equal 0. The k can't equal 0 one's done already. That's awesome. 2k minus 1 can't equal 0. What could I do? How do I get k by itself? Plus 1 divided by 2. We always, when we're solving for a variable, you guys, from an equation, we always do reverse bedmaster rules. So we're going to do addition and subtraction first, then multiplication and division second, okay? Then exponents last. So we're going to add 1. 2k cannot equal 1. Then divide by 2. K cannot equal a half. And so our Npvs are k can't equal 0, comma, a half. If it equaled 0 or a half, we'd have problems. And people don't believe me. Well, if it equals 0, it's going to be 0 times 2k minus 1, which is 0. Okay? If I put in a half, it's going to be a half times 2 times a half. What's 2 times a half? 1. 1 minus 1 is? This bracket becomes 0 times a half is 0. Their denominator is still 0. Okay? You're going to do C and D. Hint at D, it's a difference of squares. And by hint, I mean I just told you. So do C and D. C, what could I take out of the denominator? A 2. And the 2 is in its own brackets, right? So I'd have 2 can't equal 0, which is true. But does it give me an NPV? Some people say this. Now, please pay attention because I don't want this to be you, and I get it all the time. 2 can't equal 0. Okay, well, then I have an NPV of 0. Is that true? 2 can't equal 0 means I have an NPV of 0? No, 2 can't equal 0 means that's true. That's just a true statement. Yay. It doesn't get me an NPV. I only get non-permissible values based on what? Variables. That doesn't have no variable. It doesn't have one. Nope, it doesn't. I just went Southern for a second there. And Southerns would be like, no, you didn't actually. You just sounded like an idiot. I'd be like, yeah, that's true. All right. Okay, I got called ma'am once by some Southerners. And I was like 21. And I was like, I don't think you can call me ma'am. I think it's just wrong. I think they were older than me. It was strange. But it was super respectful. I was just not used to it. -5. And m can't equal -5. So that's my only NPV, right? 0 is not. And this one, x plus 7, x minus 7. So I get x plus 7 can equal 0. X minus 7 can equal 0. X can't equal -7. X can't equal +7. And that's fine to leave them separate. And it's also fine to write them like this. -7 comma +7. Or just 7. But what they'll often write them as is x can't equal +, -7. Okay? Then you're going to flip over. So this is your turn. That's your homework. We're going to go through it tomorrow.